Hello, everyone, and welcome back to Learning with Jelly. Today is day 4 of our 30-day SQL challenge. If you've made it this far, I want you to celebrate yourself, celebrate those big and small wins because you are well on your way in learning SQL fundamentals to land your next data role. On day 4, we're going to talk a little bit more in detail about databases. So let's look at our agenda for today. Our agenda for today is we're going to discuss database types because there's a lot of different database types. Though we won't cover every type of database in this 30-day challenge, I want to make you aware of the different types of databases that exist, just in case you encounter them in the industry or just in case you want to learn them on your own. We're going to talk about data types, which is going to be very important to know before we start writing our queries. We're going to revisit this concept of primary and foreign keys. I talked about this briefly in day 1 about what a primary key is, but I want to reiterate it during this talk because the more you hear it, it will solidify. Then we're going to talk about database constraints and rules that you can apply. We're not going to go in super detail about this, but for those who are interested in data engineering, this is definitely an important slide for you. Finally, we are going to talk about ERDs, which is entity relationship diagrams, and then hop into SQLite Studio so that we can look some more at its functionality. So, if you're new to the challenge, welcome. The whole goal of this challenge is to work for 30 days, preferably straight. I know consistency is hard, but the goal is to work for 30 days straight on learning beginner to intermediate SQL skills to land that next data role, whether it's a data analyst, a junior data engineer, whatever it may be. On the left hand side of your screen is a QR code for a topic list where you can see the topics for the 30 days. You also can see any additional resources that I feel will be helpful for you to know in that document as well. Have no fear if you don't scan it, the link is going to be in the description below. But so that you don't miss any videos for this challenge, hit the notification bell so you're notified. On the right hand side is a QR code to join our amazing new Facebook group. There is a 30-day SQL challenge chat where you can ask questions, get feedback, and find a study buddy. And that will also be linked in the description below. So let's talk about the different types of databases and what is a database at its core. A database is nothing but an organized collection of data. So there are several types of databases, and I'm going to highlight the main types of databases as well as the software that kind of does this database style so that you can research it on your own if it's of interest to you. So what we're going to talk about in the 30-day challenge is the relational database. It's where we store data in tables. So we just have rows and columns. And examples of this is customer records, healthcare records, financial transactions. And some of the tools is SQLite, which we're using in this course, MySQL, and Postgres. So relational databases have relationships between this structured data. So the data is very structured in the fact that it's stored in these structured rows and columns. Next, you can move towards more unstructured data. And one example of that is a document database where you can store data as JSON documents. And a very popular tool out here for this type of database is MongoDB. So you can store property listings like from Airbnb or real estate that may be of a document form, user profiles that may be of document form in a database as well. So not as structured. Then there are key value databases, which, if you know anything about coding, and it's fine if you do not, key value pairs are very specific to dictionaries. So, a software that does this is Redis, where they're going to have a key, which could be a text or number. In this case, let me just say that is session number 5. And the value is going to be my IP address. So anytime when you want to store data like that, session management for when you visit a website, you may have a key value database. There's also column family database where data is stored in columns rather than rows. An example of this is Cassandra, and that's good for time series data when we're tracking data across time. And then we have more graph based databases where you're storing data as nodes and edges and kind of looking at the connection between all of the nodes. And this is good for like social network analysis to see who knows who, as well as recommendation systems when we're recommending you similar products or similar movies on Netflix. So all of these are main database types. The type of database that we're going to focus on in this challenge, once again, is relational database. So, if we dive more into these relational databases have rows and columns. And the columns have specific data types that define the type of data that's stored in that column. So, these data types could be integers, such as your age. It could be text, such as a column that stores email addresses. It could be real numbers, such as a column that also stores your age. So there's different data types. And these data types can be found in the schema as well as many entity relationship diagrams or ERDs, which we'll talk about momentarily. And what the schema is by definition is just the structure of the database. This is a database. This is how many tables are in the database. These are the data types of every column within the tables. These are any constraints, and we're going to talk about constraints momentarily. But say, for instance, you need a constraint where this column has to be unique, or you need a constraint where you can't have any missing data in this column. And it's also going to store indexing that allows us for just fast retrieval of things. So it's important to check on data types because not all functions in SQL work on all data types. So for instance, there's no need for me to get an average of an email address column. What is the average email? That wouldn't make any sense. Okay. It wouldn't make any sense if I'm trying to get the average age, but age on the back end is actually stored as text. So then it tells me that I would have to change age from text to number. So that way I can get the average age. So we definitely want to check those data types of our tables first before we start querying, because once we start getting weird errors, sometimes it may be a data type error. So let's talk about the keys. So as I mentioned in day one, tables have keys, and they have these two main types of keys: the primary key and the foreign key. And the primary key, to me, is most important, is the unique identifier for each record in the table. So what column or columns, because it can be more than one column, uniquely identifies every single row in that table. The less columns you can make the primary key, the better. So don't try to make the primary key across 4 columns. That would make no sense to people. And the primary key cannot be null, meaning it cannot have a missing value. So some examples of unique identifiers is like a book ID, a patient ID, a transaction ID. This column will uniquely identify every single row in the table. And if you don't have a column that uniquely identifies every row, you can create a new column that's just a count. That's just going to auto increment the row number. So it's going to start with row 1 and call it row 1, 2, 3, 4, 5, 6, 7, 8, 9, and it will never repeat a number. But it needs to be a unique identifier. In a foreign key, it's just a field in one table that links to a primary key in another table. And I'll show you an example of this, but pretty much what column in table 2 links to the primary key in table 1. And that would be the foreign key. Now, this snapshot of code, which we will create tables down the road, but it's creating a table called albums. And it has 3 columns here: album ID, title, and artist ID. Notice that it also has those data types that I talked about. The album ID is an integer, the title is text, and the artist ID is an integer. And this is straight from the Chinook database, which we will be using throughout this challenge. And notice the album ID is the primary key. So each album has its own unique album ID. And I don't have to put is not null here because it already knows when I say primary key that it can't be missing. So this is an example of how you would create a column as a primary key when you're creating new tables in a database. So let's talk a little bit about those constraints and rules. So the goal of having constraints is rules to have data integrity and consistency because we want to make sure people are filling in data at a standardized format to make our lives easier when we're doing analysis. So these are some of the constraints, not all, but as I've already talked about primary and foreign key, with primary key ensuring that you have unique and non-null values. Unique means that all values in a column are unique. So you can have another column that is unique, but not the primary key. Not null means that a column cannot have missing values. A check can ensure that a value meets a specific condition. Say, for instance, I know for a fact that anyone who is using my site had to be born after 1900. So if they put a value less than 1900, I'm going to flag it because that would not be correct. Default sets a default value for a column if when someone's entering data, no value is specified. And it's important to know a lot more of these rules and constraints. If you want to be a data engineer, you can look up more rules and constraints of SQL and creating databases, but it helps us with data integrity and consistency and standardization. So this example here, we're creating this employees table, and you can see some of these constraints. The employee ID is the primary key. It should be unique for every employee. The name, I don't want the name to be missing because if I don't have the person's name, I can't call them up. Okay. The email, I want to make sure people aren't using the same email over and over again. So I need it to be a unique email. I only want people who are greater than or equal to 18 adults to access this site. So I'm doing a check here. And I'm also doing what we call a reference, where in the employees table, the foreign key column department ID should reference department ID in the departments table. So you don't need to know all the rules and constraints, but I want to bring it to your awareness that there are rules and constraints. And we're going to talk about this a little bit more when we're creating our own tables. But definitely, if you know you want to be a data engineer, this is another topic you should dive into. Okay, so entity relationship diagram. So the purpose of ERDs is to visually see tables, the columns that exist in each table, and the relationship between the tables. So this is like a visual representation. This is very important, especially when you want to design a database. Once again, a role of a data engineer as well. Sometimes you may have a table in this department, a table in that department, and you want to visually draw it out first to see how these tables can relate to one another. And an ERD would be that. It's also great for documentation purposes. I can't stress enough, the better your documentation. If you go into the industry and you're making good documentation, put that on your performance eval that I've created good documentation, because sometimes processes are very slow because we don't have great documentation. So really embody documentation. So let's look at an ERD for our Chinook database. If you're not using a Chinook database, that is perfectly fine. If you're using Northwinds, go ahead and Google ERD for Northwinds database. It will come right up in Google Images. If you have not downloaded the Chinook database, I'll put a link in the description below. But as you can see, the orange rectangles or boxes are a table. So we have a table of media type, a table of genres, playlists, tracks, albums, etc. And within this ERD, a yellow key denotes the primary key. So, for example, in media types, the media type ID is the primary key of this table. And notice that this data type is integer. If you see something like varchar, that means character. So, this one is more of a character, basically a text field that has a max of 120. So you can't have somebody to put a name that is greater than 120. But in this case, this primary key of media type ID relates to the foreign key media type ID in the tracks table. So media type ID is the foreign key that relates to the primary key of the media types table. Okay. So that is what that foreign key is. It is the column that links to the primary key of another table. And you can see that this is in a separate table. Okay. So you can get the relationships on how you can link and join these things together, which is going to be important when we talk about joins in future videos. Okay, so now since we have talked a little bit about databases and their structure, let's look at how we can actually look at this at SQLite Studio. So I'm going to open up SQLite Studio. And here we have a nice little query that we did from day 3. So if you exit out, you might see yours pop back up as well. I don't see my databases on the left-hand side. Have no fear. I can go to view. I see databases is in check, so I'm going to check it and it pops right up for me. So this is more of a visual representation of our schema. Chinook is our database and we have 11 tables. If I want to expand the 11 tables, I see that we have albums, artists, customers, employees, and so forth. But let me double click on employees. And when I double click, it brings up this small box on the back end of it. And when I expand this window, so let's kind of get the little black thing so we can kind of expand this and kind of see what's going on here. Sometimes it's hard to kind of really expand these boxes. Oops. Did it go away? Show all my windows. Oops. Went away. That's perfectly fine. I'm just going to double click on it again. And I'm going to expand, if it lets me, the box at the bottom. Sometimes these softwares is a little finicky where it's not letting me, of course, expand, but this happens. All right, now I think I got the perfect thing. Okay, so now that I have expanded some, we can see the columns inside this employees table. We see employee ID is integer. It's the primary key. It can't be null by that symbol there. We see last name is a character. It has to have a max of 20. It cannot be null. We see first name is a character with a max of 20. It also cannot be null. So we have all the information here about our table employees, okay? And I can probably type in another one. Let's just type in genres here. Okay. And it may switch to genre. It may not. Doesn't look like it. But another way that I can do this is I can expand the genres table and then expand columns and double click. And it tells me here that genre ID is an integer. And I can check off these things. Say, for instance, I want to say, hey, you don't have to have the genre ID. I can uncheck it. I don't recommend that. We're not going to make any changes, but just in case you need to see the structure, which I always recommend, we want to make sure that we double click on our actual table and kind of expand the box so we can see all of our data, okay? And we can scroll down and kind of see what's going on there, okay? All right, so let's hop back and wrap up about what we learned today because we learned so much. All right. So we've learned the various types of databases. There's tons of types of databases out here. I highly encourage you, if you want to be competitive in the industry, definitely look up resources on document-based databases from MongoDB. If you're really interested in data science and making machine learning algorithms, definitely look up Neo4j as far as recommendation systems. But there's tons of different types of databases. Databases have keys. They have a structure known as a schema. Your primary key cannot be missing and must be unique to every row. There are rules and constraints when building out databases. And there are great entity relationship diagrams called ERDs that help you get a layout of the land. Thank you all for watching this video. As always, please like, comment, and subscribe. Feel free to shop on my Etsy for apparel, which we'll have the link in below. If you want me to continue to make great content for free, please click in the link below to buy me a coffee. I would greatly appreciate it. Subscribe to the channel and follow me on LinkedIn. Thank you so much, and we will get started on day 5 tomorrow. Bye-bye.